All right, let's start with an example on this expanding and evaluating exponents real quick, and I'll talk about all the terminology and everything as we go along. So right off the hop, let's talk about the whole thing. This whole term can be considered a power, okay? A lot of people, like I've said in other videos, I don't even know if it's in this course, but they'll call the exponent, which is this little 3, they'll call that the power, which is fine, it's acceptable. I mean, you'll never hear me sweat about it. Lots of people would, but you'll never hear me care about it. This larger number we call the base. Okay, so if I'm referring to the base, I'm always talking about the bottom number. So now the whole thing can be called the power. So 4 to the power, or the exponent of 3 is the power of, and go like that. The terms don't mean much. I just want to make sure that you understand when I'm saying the base, I'm talking about the lower number. If I'm talking about the exponent, I'm talking about the uppercase, smaller number above the number. Now, when we talk about expanding, you got to remember that the general rule, and I'm going to write this down, the general rule, and yes, that's the best writing I have. General rule for exponents is you multiply the base by itself that many times. And by that many, I mean the number of the exponent, right? That many times. So for instance, in this question, we're going to go 4, and I'll use an x, which I never use for multiplication really, times 4 times 4. So we've used the general exponent rule to expand this out. So this is in the expanded form. I'm going to write that now. I'll write it in green, just change it up. This is what we call expanded form. So if I said write in expanded form, this is what I'm looking for. If I said write in exponential form, that's up here. So something that was given to you in expanded form, I might say write in exponential form. Pretty straightforward. Okay, so 1, there's an exponent, 1, there's not. Okay, so you've expanded. Now, if you were to, if I said to evaluate this, now you can go back to your expanded form and just simply go 4 times 4 times 4. And I've said this again in other videos and stuff like that. My expectation is that you know all your perfect cubes, so anything with the power of 3 up to 6. So I, in grade 10, should know what 4 to the power of 3 is right off the top of my head, and we get the answer of 64. Okay? So maybe I'll write that out on the next page as we do another example before we get going. So you should know all your perfect squares, because we don't use a calculator very much in this course, because it's not about the answer so much as it is understanding. So you should know all your perfect squares up to 15 squared. That's what I would expect. So all the way up to 225. Okay, so that's 2 squared, 3 squared, 4 squared, 5 squared. You should know all your perfect cubes. All your perfect cubes up to, I think 6 is lots, but as you get going, you'll automatically, know what 7 is and so on and so forth. So I would say up to 216. And after that, like I'll say power of fourths. So your fourths, I would say probably up to a base of 3 or 4. So up to 3 to the 4. So that if you expand that out, you get 9 times 9, so you get 81. So that's pretty straightforward. And then after that, so I'd say greater than exponent of 4, just base 2. Okay? And I really, really, really believe you should know your base 2's all the way up to 2 to the 10. That's what I think you should know. You should know what 2 to the 6 is, 2 to the 7, 2 to the 8, 2 to the 9, and 2 to the 10. After that, who cares? But 2 to the 10, I mean, you just keep multiplying by 2. You keep doubling a number. It's pretty simple to do it in your head. Okay, so that's my expectation. So let's get going here, and you can press pause and finish writing this stuff down if you need. But I'm going to do another example of just expanding. All right, so in the expanding, we could have a to the 4, like that. Well, expand that, you get a times a times a times a. So there it is, written in expanded form. Can't really evaluate that, but there it is. Let's do another one. Let's go -3 to the 5 in expanded form. Well, that's negative. And now watch, this is something you should have learned in grade 9. That negative is actually not with the power of 5. That 5 is only in charge of the 3. So that actually is written out like this. -3 times 3 times 3 5 times. And of course, we could try and evaluate that, but I'm not worried about that right now. Again, it's not a huge deal to me. Now, I'm going to show you something very similar. So -3 to the 5. Again, you've seen stuff like this in grade 9. So now if I expand this one, this now, the 5 is in charge of the whole -3, and I've got to put the brackets in there to separate everything. So 5 times. Now your answer might come out the same, but the expanded form has to be shown properly, okay? So I'm going to do a couple more examples that kind of link this, and we'll evaluate and see how the answers do work out. So let's start with, let's just use base 2's because they're real simple. Let's go -2 to the 3. We'll go -2 to the 3. We'll go -2 to the 4. And we'll do -2 to the 5, or sorry, to the 4, but in brackets. So we're going to see what makes difference and what doesn't, and then we can kind of come to a conclusion just as number sense, sort of like from grade 9. So this one here, if I expand it, I get negative, and then that 3 is responsible for only the 2 at this point, so 2 times 2 times 2. That, in the end, and I shouldn't put my equals across the page like that. If you're doing that, don't do it. I'm doing it because I'm saving space here. Do it, work down the page all the time. So you get -8. So 2 times 2 times 2 is 8. And there it is. So now, this one, I write this out, I get -2 times -2 times -2. I go ahead, I look at the 2's, I get an 8. I look at my signs, I get negative times a negative is a positive, times another negative is a negative. So there, I get the same answer. Now look at the exponents. What do you notice about the exponent? Okay, I'm going to let you sit on that for a bit. Okay, now let's jump down to this. I'm going to switch to red just to separate the question here. I'll draw a line and everything. Okay, so now in this case, you get negative. Now I got 4 2's I got to write out. Because again, that exponent's only with the 2, not the negative. So I write all that out. I get 16. 2 to the power of 4 is 16. With a negative that's sitting out front like so. Square that off. Good. Happy. And this one, the -2. 4 times, because the power of 4 this time is responsible for the whole bracket. And multiply all that out. I get 2 to the power of 4 is 16. Now look at my signs. I get negative. Negative is positive. Negative is negative times a negative is a positive. So this time I get positive 16. So now when you look at the exponent of this one, what can you say about this exponent? Because it's going to be true for all exponents that are similar. Well, I hope you came up to the conclusion that this exponent was odd and this exponent was even. So that's the big difference, and that's why our numbers are affected the way they are. Okay, so for instance, in our first example here, our -2 cubed and our -2 to the power of 3, our answer is going to be the same because the exponent is odd. It really affects us, though, if our exponent is even, okay? Anyways, that's a little bit further than I even wanted to go, but I'm glad we did it. The main thing is that you know how to expand, and you see that even on this page. So make sure you can expand and evaluate is just give your answer.